Hi ladies, this is Mrs. Blaufuss, and today we're going to talk about congruent angles. So our vocab term, which you have seen before, is vertical angles. For today is October 9th, 2019. Okay, so this is the video that goes along with the October 9th notes. Okay, so we're talking about congruent angles. You've heard about vertical angles. We've discussed vertical angles before. We're going to define vertical angles, and these are angles formed by intersecting lines that share a vertex. Okay, so a diagram of vertical angles might look something like this. Okay, where angles 1 and angles 2 are vertical angles. Okay, so here's their shared vertex. The angles are formed by the two lines that intersect. And we have a theorem that goes along with the vertical angles, and it's that vertical angles are congruent. If you remember the term complements, the term complement or complementary angles means angles that sum to 90 degrees. So congruent complements theorem says that if two angles are complements, or if two angles are congruent, then their complements are also congruent. Okay, so this just means if we have a 60-degree angle, which is congruent to another 60-degree angle, then their complements have to be 30 degrees for both of them. Okay, so let's draw a little sketch. Okay, so here's one angle, and here's another angle. Oops. I'll draw it the same way. Okay, so if those two angles are congruent, that means that their complements would also have to be congruent. So if angle 1 is congruent to angle 2, and angle 3 and angle 4 are complements respectively to angle 1 and angle 2, that means that angle 3 and angle 4 also have to be congruent. So let's look at this converse. Remember, the converse switches the if and the then part of the statement. So we're going to reword it just a little bit so that it actually makes sense as a theorem. But the converse of the congruent complements theorem says that if two angles are complements to the same angle, then they are congruent. So for example, let's say that angle 3 is a complement to angle 2 and angle 1. That means that angle 1 and angle 2 have to be congruent. So if angle 3 is a complement to angle 1 and angle 2, then angle 1 and angle 2 are both congruent. Okay, we're going to use the same idea for these complements theorems to define our supplements theorems. So the congruent supplements theorem, remember, supplements are angles that sum to 180 degrees. So the congruent supplements theorem says if two angles are congruent, then their supplements are congruent. And then the converse of that is just like the converse of the congruent complements theorem, but again, we're talking about supplements. So the converse of this is going to be if two angles are supplements to the same angle, then they are congruent. So to define supplementary angles in our diagram, I'm going to use a line just because we know that a line is 180 degrees and all linear pairs are supplementary. Okay, so I'm going to use this line. So it says if two angles are congruent, so let's do this twice. Okay, so if two angles are congruent, and let's say this angle is congruent to this angle, then their supplements are also congruent. That means that this angle has to be the same as this angle. And then the converse says that if two angles are supplements to the same angle, then they are congruent. So I'm just going to label these angles 5, 6, 7, and 8. So in our congruent supplements theorem, we said that if angle 5 and angle 8 are congruent, then their supplements are also congruent. That means angle 6 has to be congruent to angle 7. The converse of that is saying that if two angles are supplements to the same angle, so let's say if angle 7 and angle 6 are supplements to angle 5, then angle 7 is congruent to angle 6. And I'll just use the congruent sign. Oh. Okay, so now let's use these theorems and we're going to apply them to a couple examples. So let's look at the next, and it says that suppose angle J is congruent to angle K, and the measure of angle K is equal to 35. Okay, so we know that the measure of angle K equals 35 degrees. What's the measure of angle J? We know it's congruent to K, so we know it's also 35 degrees. And we're trying to find an angle that's complementary to angle J. So to answer this question, first we need to know angle J, which we do, it's 35 degrees. And to find an angle that's complementary to it, we need to take 90 minus 35 because the two together have to add up to 35. So some angle X plus angle J has to equal 90. So 90 minus J is going to equal X, which equals 55 degrees. Oh, there's my email. All right, here we go. Now the second example is using the same kind of idea, but we're going to use that theorem that says if two angles are supplements to the same angle, then they have to be congruent. And if two angles are supplements to the same angle, then they are congruent. So in the figure below, it says angle 1 is supplementary to angle 2. Okay, let's stop right there. What does that mean? If angle 1 and angle 2 are supplementary, then they have to add up to 180. So angle 2 has to be 130 degrees. Then it says angle 3 is supplementary to angle 2. So 3 and 2 together are supplementary. They have to add up to 180. So therefore 3 plus 2 equals 180. So a measure of angle 3 has to be 50 degrees. So in this example, we know that angle 1 and angle 3 are congruent because angle 1 is supplementary to angle 2 and angle 3 is supplementary to angle 2. So we know that angle 1 is congruent to angle 2. because they're supplementary to the same angle. All right, let's look at this next example. It says in the figure below, angle 1 is complementary to angle 3, and angle 2 is complementary to angle 3. So what do we know about angle 1 and angle 2? Without even solving, we know that angle 1 and angle 2 are congruent because they're both complementary to angle 3. Now it tells us that angle 3 is 25 degrees. So from there, we can find angle 2. Because 2 and 3 are complementary, angle 3 is 25 degrees. So angle 2 has to be 90 minus 25, which is 65 degrees. I don't have to do the math again because I already know that angle 1 and angle 2 are congruent. So without even doing anything, I know that angle 1 is 65 degrees. Now, if you want to go one step further, the 4 of those angles together form a straight line. A straight line measures 180 degrees. So from there, we can find the measure of angle 4 as well, because the measure of angle 4 is going to be equal to 180 minus the other 3 angles, minus 65, and minus 25. And if you do this, it doesn't ask you to, but if you do, you get the measure of angle 4 is equal to 25 degrees. Okay, because together those 4 angles have to form a straight line. They add up to 180 degrees. And then the last theorem, this right angles theorem, all this says is that all right angles are congruent. And then the second part of this is that if 2 angles are congruent and supplementary, then each angle is a right angle. Okay, so if we have, we'll just, again, use a line. We're going to use a linear pair. But if we have 2 angles that are congruent and they're supplementary, that means that each one has to be 90 degrees, because 90 plus 90 is 180. Those are the only 2 angle measures that are congruent that add up to 180. Okay, and then make sure that when you mark right angles, you mark them with that little box. So please jot down any questions you have from this lesson, and then we can go over them next time I see you in class. Thanks, ladies.